Now let us discuss their property of formation of colored ions. See, transition element forms colored ions, which can be green, purple, red, violet, any of these colors. Now they form colored ions mainly because of the presence of unpaired electrons which shows dd transition in their splitted d orbitals, and that is why they are able to show color. See, both these conditions are very important, and only the presence of the unpaired electrons will not make them colored. The example I can give you is, we know copper sulfate mainly exists in the form of this complex. The copper sulfate, normally which we write copper sulfate dot 5H2O, it exists like this. Now water being present as a ligand causes the splitting of the d orbitals, and as a result the copper which is existing in its +2 state is having a 3d9 configuration and is having one unpaired electron. That unpaired electron shows dd transition. Now when this is heated and we get an hydrous copper sulfate, since there is no water as a ligand, there will be no splitting of the d orbitals, so no dd transition. So in spite of a copper existing in the same 3d9 configuration, having same one unpaired electron, it is white without any color. Therefore, the dd transition is must for showing the color by these transition element ions. Transition elements have very high tendency of formation of complex compounds. So now let us discuss what makes them to be having such a high tendency of forming so many large number of complex or coordinate compounds. See, we know complex or coordinate compounds are like this: Fe, CN6, 4 minus, Fe, CN6, 3 minus, Fe, F6, 4 minus, Mn, C2, O4, thrice, 2 minus. So like this, we know we have a number of examples where we find that all these elements have very high tendency of forming these complexes or complex compounds. Now what makes them this to have such a high tendency is, see, in this what we find is that, like if we take the example of ferrocyanide, the 6 cyanides are bonded to the central Fe ion by 6 coordinate bonds like this. So the central atom must have what? High nuclear charge, high charge density, small size, and of course empty d orbitals, to accommodate these 6 pairs which these ligands cyanides are donating. So why they have such a high tendency is because of very small atomic size. The second is high nuclear charge, or we can write charge density, and third is availability of partially or fully filled, partially or empty partially filled or empty d orbitals in which they accept the pair of electrons which are donated by the ligands, and these are the 3 basic reasons which make them to have such a high tendency of forming coordinate compounds.